Okay, in this video we're creating a histogram for the frequency table below. I want to point out a couple unique things about this frequency table. The first thing is you'll notice that the categories run together. So this category goes from 0 to 2 hours, and the next one starts from 2 to 4. So you might ask yourself, well, what would happen if somebody studied for exactly 2 hours? Which category would they belong to? Well, the answer is they would belong to the second category, category 2 here, because we have this rule that says that whenever there's these overlapping categories, the left endpoint convention applies. So let me just remind you of what that is. We used it in the histogram earlier, but here's an example, or a definition, sorry. The left endpoint convention for continuous data says the bars of the histogram contain the left endpoint, but not the right. This is also the convention used when a frequency table has no gaps between the classes, all right? So in other words, what we're saying is that, when we look at this category, we assume 0 is part of the category, but not 2. 2 is part of this category, but not 4. 4 is part of this category, but not 6, so on and so forth. So when it goes up to 6, they mean right up next to 6, but not including it, right? So 5.99999 is part of this category, but 6 is actually part of this one. Okay, so that's basically how that works. The second thing you might have noticed about the table that's a little strange is the fact that this last category is much wider than the other ones before it. Right? Each of these only has 2 hours in it, right? From 0 to 2, from 2 to 4, from 4 to 6, from 6 to 8. This one should have gone from 8 to 10 if it was following the same pattern as the others. But what probably happened, there probably wasn't many students in this last, categories from 8 to 10, from 10 to 12. So there might have been a lot of empty space there. So what they did instead was just sort of lump everyone into one large category here from 8 to 15. So because this doesn't have the same width as the rest, we can't create the histogram the same way we did before. If we did it the same as we did before, what will end up happening is this last category, if we made, in other words, the height of the rectangle the percentage, what would happen is because this is much wider, and the height would be based on the percent, you would end up having a rectangle that has too large of an area, and it would distort the drawing. It would make it look like a lot more people were a part of this category. So we don't want to distort that image. We want to make sure that we do the drawing in a way that's truly representative of the density of the data. So what we're going to do instead is we're going to use a different approach, and we'll talk about that approach in a moment here. I'm going to go over the steps in the next slide, and then from there we'll work out the drawing for the histogram. Okay, so let's take a look at the steps then we'll use in this special case. And the reason why we have to use these different set of steps again is because this last category is too wide. It actually has nothing to do with the fact that they run into each other, right? That whole left endpoint convention thing is actually really nice because then we don't have to use class boundaries here, right? There's no need to come up with class boundaries if they already we already have categories that don't have spaces between them. Remember, we created the boundaries because we had spaces between the categories. Here we get to skip that step, so this is actually easier in that regard. What makes it a little different, though, is this fact that this last category or class is too wide. It's wider than all the rest, and because of that, it's not a uniform class width throughout the table. We're going to have to use a slightly different approach to do the drawing. Let's look at how that's done. Okay, so here are the steps we're going to use to create the histogram for this example where the class width is not uniform throughout the table. All right, so steps 1 and 2 are done for us in our problem already. We already have the classes created and we already have the frequencies for the problem. They're filled into that table. We're going to do step 3 pretty easily. We're just going to convert the frequencies into percents. That'll take no time at all, and that's easily done and well understood. Let's look at part 4 though. For each bar, it says find the height. So remember in geometry, we learned that the area of a rectangle is height times width, or length times width, right? So height times width, if that's the area, if I'm trying to solve for height, I would divide both sides by the width, right? If I divide the width here off and then I divide it into area, height becomes area divided by width. So remember here also that area is the same as the percent, basically. So when I look at my statement here, I have to figure out, okay, well, how do we express this using the information in the table? Well, area is going to be the percent, right? And the height of the rectangle is what we're solving for, so we don't have to worry about what that is, but the width itself is actually the width of the class that we're working with. So the specific class that we're dealing with, that's going to be the width. So in most of our table that we looked at, I think the width was 2, but the last category wasn't 2, so that would be the one that's different. All right, and then from there, in step 5, we're going to draw and label the x-axis, and y-axis, like we've done before. The y-axis is going to be called the density scale. So that scale is going to be equal to the percent per x unit. So what that means is we're going to divide the percent by the x unit that we've labeled on the x-axis. So in this case, for our example, the x unit is going to be time. It's going to be hours, basically, because the data is basically the number of hours spent studying per week. So our x unit in this problem is going to be hours. So we're going to have percent per hour. And it's a funny unit, but that's basically what it is. And we can kind of explain that once the drawing is up. We'll explain how to interpret that. And then lastly, we're going to draw in the bars, and that's the easy part as well. So the main thing here, the main difficulty is that we're going to have to find the height of the rectangle, how high the rectangle should be, and then we're going to have a different y-axis, right? And the y-axis is going to be called the density scale, and it's going to be equal to percent per x unit. In this case, it'll be percent per hours for our example. All right, so those are the steps, and sometimes it's easier to just do them than to explain them. So let's go ahead and start working on this problem. Okay, so you can see what I've done here is I've added up all the frequencies to get the total frequency, or the total sample size for the problem. So now that I have that number, what I'm going to use is that number to come up with the percents for each category, or the class percents. So the way that's going to be done is essentially I'm going to divide each of these values by 175, then multiply it by 100 and convert it into a percent. So just remember though that the percent is also the area of our rectangle. So let's go ahead and do that now. Let's get all the corresponding percents. Now, I've actually done this already, so I'm just going to do a couple just to show you how it's done. It would be 28 divided by 175. And that gives you a decimal of 0.16, and you move the decimal place over twice to make it 16%, right? So your answer here would be 16. If I did that for the others, and I've already done that here off to the side, so it'll be 41, it'll be 25 for this one, 12 for this one, and 7 for this one. Okay, so that's the percentages for the corresponding classes. Now, and again, remember, those are the same as the area of our rectangle. Our rectangle should have that area for drawing the drawing properly. Now, from there, what we want to do is to come up with the heights of these rectangles. We're going to need this to do our drawing as well. We're going to need to know how tall to make the rectangle so the picture looks proper. So to come up with the heights, I want you to remember that heights are the same as the area divided by the width. But you may ask, how do we get the width? Well, the width is really easy. If we know the area is the percent, the width is simply just the difference between the two class limits, right? So how far apart are these two numbers? It's 2 apart, right? 1, 2. And then here it's 3, 4, that's another 2 apart. And 5, 6 is 2 apart. And 7, 8 is 2 apart. How far away is this? Well, that's 7 away, right? It's 7 steps to go from 8 to 15. So the width is 7 there. So we'll divide this percent by 2 because the class width is 2, and that'll give us a height of 8, right? And then so on and so forth. If we divide 41 in half, we'll get 20.5, right? And if we divide 25 in half, we get 12.5. And if we divide 12 in half, we just get 6, right? And if we divide 7, not in half because it's not a width of 2, it's a width of 7. If we divide 7 by 7, we get a height of 1. Okay, so those are our corresponding heights for our rectangles. And now that we have all those, it's time to do the drawing, basically. And to do the drawing, we're simply going to draw an x and y axis. We're going to make the rectangles this tall. We're going to use this for our x-axis. And then the y-axis is going to be, essentially a unit of percent divided by hours, since these are hours, right? The width is hours, right? It's a span of 2 hours. And the height of the rectangle is going to be comprised of the percent divided by those hours. So essentially, we're going to label the y-axis percent per hour. Okay, so let's go ahead and do that now. Okay, so let's do our drawing finally. So we're going to draw a y-axis, which is going to be labeled percent per hour. Hour again, because that's the units of our x-axis. And our x-axis is going to be the hours that are listed there. And so we'll have 0, we'll have 2, we'll have 4, we'll have 6, we'll have 8. And now here's the tricky part, right? We want to go over to 15. You don't just want to draw a line and say 15, right? You don't want to do that. You want to try to make it roughly where it should be. So maybe this would be where 10 would be, and this would be where 12 would be, and this would be where 14 would be. So 15 is going to be a little bit after that, maybe around there, okay? So just a little indication of where 15 would be. So 15 is going to be somewhere down here, right? Because it'd be 9, 10, 11, 12, 13, 14, and then 15. So that's roughly how far. We need to make the scale accurate. So you can't just put 15 here and show that space as representing a distance from 8 to 15 if this distance was from 6 to 8, right? So if this is supposed to cover a unit of 2, then that should be 2 and 2 more and 2 more and then 1 more, right? So that's roughly approximately correct. All right, now once we have that, the percent per hour, if you look at that, that's this scale here. And it looks like we have a maximum value of 20 and a minimum of 1. So we're going to kind of cover that span. I'm going to try to do 5 intervals of 5 just to make it easier on us. Of course, you know, the finer you make the scale here, the easier it is to see. But let's just call this 5, 10, 15, and 20. Remember, these are 20% per hour, 15% per hour, so on and so forth. Let's do the drawing now. To do the drawing, we're going to make the rectangles the appropriate heights. Luckily, these run into each other, so we don't have to worry about getting boundaries. So we're just going to go from 0 to 2. We're going to make that height 8. So if that's about 8 on our drawing, we'll do it there. There's 8. And then from here, from 2 to 4, that's supposed to be 20.5 tall. So just a little higher than 20, right? And then we'll do for 4 to 6, we'll do 12.5. It's a little higher than 12. We're actually right in the middle between 10 and 15, I should say. And then we'll have, and this should be the same width. I've kind of messed up my drawing a little bit. I didn't make it nice and evenly spaced, but you know, it's supposed to be evenly spaced, at least for those values. And then for the next one, for 6 to 8, it'll be a height of 6, so just a little higher than the 5, right? So maybe like there, for example. And then we have this long rectangle that's going to be kind of short but wide. Remember, the height is only 1, right? So we're going to kind of say, well, maybe 1 is right there. So it's going to look like that. And that will be our last rectangle. And that's it. Right? And if you wanted, you could pencil in what the height is. But that's essentially our drawing. So you see, this is an appropriate histogram that relates to this data. If we had just used percent instead of the other way around, we would have had this rectangle as tall as 7, right? And it would have been disproportionately large. What we're showing here now, the way this unit works, is it's kind of like if you're walking along the x-axis, this is representing the density. You can almost think of it like population, right? So, you know, or if you're walking through a forest, it would be like, you know, the density of the growth, right? When you're walking here, you know, it's fairly dense. Here you get a lot of density, right? The same distance, you get a lot of like foliage or trees, you know. This is pretty dense, still dense, but not as dense as the other ones. And then you see this area is virtually barren, right? Not much here. And that's captured by the drawing appropriately because we use this percent per hour setup. And so that's really a great histogram. And the visual pattern is true to the data as we see it in the table.